Okay guys, we're going to talk about angles and their measure. So, sorry, I think it's a little blurry, but you can follow along. If it's too bad, I'll try again. Y'all just let me know. It says, choose the figure that shows an angle of negative pi radians in standard position. Negative pi just means we're going standard position, start along the positive x-axis. Negative means we're going to go this direction, right? So negative pi is 180 degrees, so we go negative pi in this direction, it's gonna be C. This would be negative, or actually, this would either be negative 360, this would be negative 90, so now you're probably pretty good at that. The next one says draw an angle of 495 degrees. Okay, so we need to go past 360. So if you're looking here, I've circled the right answer. 360, we go around once, then what do we have left? 135 degrees. So then we have 90, 45. It's gonna be A. You don't have to convert them if you don't want to, but if it helps, go ahead. Next one, convert 195 degrees to radians. So if you're converting degrees to radians, you multiply by pi over 180. Notice this first time I just divided both of these by 5, and I got 39 pi over 36. Then I realized, oh, I can divide that by 3 too. So I got 13 pi over 12. Now we're going to go in the opposite direction where we are, we're going to find the reference angle of the angle. So if it's 13 pi over 6, you can go ahead and convert to degrees if you want, if that helps you. So the reference angle means the smallest angle, acute angle to the closest x-axis. So I converted it to degrees here first. So if I go 390 degrees, that's all the way around and then up 30. So we're to the closest x-axis here. So our reference angle is just 30 degrees in this case. Next one, it says find the reference angle of 675 degrees. So I've tried to draw 675. So we go 360, then a complete second time around would be 720, but I'm not quite there. So I do 675, and I realize, okay, well this is going to be my reference angle because I'm in quadrant 4. What's the measurement from here to the closest x-axis? 45 degrees. Okay, the next one has us converting decimal degrees to minutes and seconds. So the decimal degrees is, we have to fill in degrees, minutes, and seconds. The first thing I do is I keep taking whole numbers. So I take the 79, I make those degrees. Then I take the 0.38, I multiply by 60, and I get 22.8. So take the whole number, that's minutes, then we multiply by 60 again. 48, that's going to be my seconds. Now if we're going the opposite direction, what you're going to do is you're going to add 79 plus 22 over 60 plus 48 over 3600. You would get back to this term right here. So just make sure you are kind of familiar with doing both. The next one, it says find the length and the sector area. So the arc length is just r theta. So my radius here is 6. My theta, which must be in radians, is 3 pi over 4. I get 18 pi over 4, but I reduce it and I get 9 pi over 2. Now my area is 1/2 r squared theta. And again, my theta has to be in radians. So I do 1/2 6 squared 3 pi over 4. After reducing and everything, I get 27 pi over 2. I have one more sector area problem. So on the second page, it's hard to see it, but it's the sprinkler. So the sprinkler goes 120 degrees. Well, 120 degrees, I convert it to radians because in my formula, I need radians. So my area is 1/2 r squared theta. This is what I use for theta. This one, they actually asked for a decimal. So I said my area was 1/2 40 squared times my theta. And I got 1,675.47. Okay, next video, guys, we move on to right triangle trig.